Okay, 16 box Punnett squares. This is what, pages 3 and 4? Well, 4 of your packet?
Yeah.
Right? Okay, so here's what we have going on. We are now following two traits at the same time, right? So I'm going to do an example. Let's do height and eye color. Those aren't the two that you have, are they? Okay. Well, it doesn't matter. Either way. So height and eye color. So let's say that Dad is homozygous tall, and he has heterozygous brown eyes. Right? Mom is heterozygous tall and heterozygous brown eyes. We got to figure out what combinations these parents are going to have. Here's what you have to think about. These letters represent traits, all right? And when parents pass on their traits to their offspring, remember they only give half of the information that they have, right? So mom gives half, dad gives half, and you get this wonderful combination of traits. Okay, so we have to figure out what the options are. So here for dad could give this big T and that big B, but he could also give this big T and that little b. Okay? He could give this big T and that one or that and that. So the T's happen to be the same, which makes it a little bit easier, but still there's these combinations that you could actually get. So we do something very similar to foiling in math. You guys remember how to foil?
Yeah.
To figure out it's just an easy way to figure out the combinations. So I literally take and distribute my big T to the first big B. I'm going to write it there. And it looks funky when you write it. But this means Dad's giving half of both of these traits right now. And I'm going to take that big T and distribute the little b. Then I'm going to take the second T and I go under to make sure I do it the right way. And now I have Dad's traits figured out. Then I'm going to do the same thing for Mom. And I'm a little tight on space, but big T, big B, big T, little b, little t, now this is weird, little t, big B, you write it that way, little t. So you check yourself, do I have a T and a B in every possible gamete? These represent gametes, sperm and egg cells. So I have a T and a B in each one of those. If so, I've done it right, for the most part. Now how do we combine them? That's the fun stuff right there. Okay? I didn't give myself enough room. You need to give yourself a lot of room. So I take both T's first. And I take both B's. I see two big T's. Now here's a fun one. I have a big B and a little b. I always write the capital letter first. I always write the capital letter first. Yes?
I was just wondering, so the father gives one T and one B, and then the mother gives one T and one B, right?
So that the offspring has two T's and two B's.
Okay.
Because you need two of every trait. Alright? So then you just keep going. And you fill in your whole 16 box Punnett square that way. Now ratios. Ratios can get messy on this, right? Okay? So the ratios, I will never make you do a genotype ratio on something like this. It'll only be phenotype. So physical traits. So you have 4 combinations of possibilities. The offspring could be tall and have brown eyes, or they could be tall and have blue, or they could be short, brown, and then short, blue. Those are the 4 options with 2 traits. So you literally go through and you count how many end up being like tall and brown. This one's tall and brown, that one, that one. So far, all of them that I've written down are tall and brown. And what I try to do when I go through is I mark them in a unique way so that I can go back and check my work. But But your numbers when you do ratios should always add up to the number of boxes that you have. So in a basic Punnett square, you should always add up to 4. In a 16-box Punnett square, you should always add up to 16. Okay? So your ratio very well could be 9 to 3 to 3 to 1. Adds up to 16. All right? That should give you a good start on that one.